At a highway weigh station, inspectors weigh each transport truck on a road-level scale to calculate taxes on the goods it's hauling and to make sure the load doesn't exceed safety limits. You also find truck scales at grain silos, quarries, and other sites that move bulk products. The key to this enormous scale is a tiny component called a strain gauge, which sends signals to the scale's computer when compressed. They make the strain gauges from a laminate by bonding paper-thin sheets of nickel iron foil, epoxy, and Teflon in a press. Then they coat the laminate in a light-sensitive chemical and apply a plastic film with an image of strain gauges in negative format. Then they expose the setup to ultraviolet light. The light-sensitive chemical reacts, imprinting the images into the laminate's metal surface. Now they have rows of strain gauges. An inspector examines every gauge and marks any flaws to be discarded. Now a technician measures how much voltage flows through each gauge. If it's too low, she raises it by rubbing off a microscopic amount of surface metal. When the strain gauges are finished, they cut them apart and send them to the load cell department. There, workers delicately tape 4 strain gauges into each stainless steel load cell. Then they solder electrical wiring to each one. The wires all run to a circuit board at one end of the load cell. And from the load cell, wiring runs to the scale's computer readout. The smallest amount of moisture or dirt would cause a strain gauge to malfunction, so they weld a cup over each one to hermetically seal it within the load cell. Every finished load cell undergoes a quality control check to verify that it works properly. The testing machine applies weight in increments until it hits the maximum weight the cell can bear, 34,000 kilograms or 75,000 pounds. The truck scale structure in which they'll install the load cells is called the weigh bridge. They begin assembling it upside down with a surface made of steel plates. To build the base of the weigh bridge, they lay out a grid of thick steel tubes and crossbeams. Workers lower a guide to help them align the parts perfectly. Beneath each load cell is a pin. In order to weigh accurately, a load cell has to be level, so it's critical to make sure this pin is level before welding on the bulkhead that holds it. Once fully welded, the weigh bridge is assembled and ready for painting. The paint equipment laces the powdered paint with a positive electrical charge and the weigh bridge with a negative one. This evenly draws the paint particles onto the steel like a magnet. In another department, they assemble the steel stand on which the load cell will sit. A welder tacks the pieces together. Then a robot does the full welding. Now that all the parts are ready, final assembly of the truck scale can begin. The weigh bridge, right side up now, contains 8 load cells at different locations. The first step is to install each load cell stand into its respective position. They insert a link on each side of the stand. They position the load cell at the top of the links and the bulkhead pin at the bottom. Then they close up the location with an access plate. The last step is to calibrate the scale. They lay a 10,000-pound weight, that's more than 4,500 kilos, on different parts of the scale to check if the digital readout is accurate. It takes a lot of time to get a truck scale just right, but it's definitely worth the wait.